Welcome back, everyone. So hopefully you had a chance to try problem C on page 3 in the notes. Here is what plugging into the quadratic formula looks like. And again, this is the first piece of work that I would like to see. You don't have to write the full quadratic formula, but I would like to see this initial plug-in work. My discriminant for this one is negative 56. Zoom in a little bit more. And then when we simplify that, the negative is going to come out as an I. The biggest perfect square we can take out of 56 is 4. That leaves me with 14 left over. So 2 plus or minus 2i, radical 14. And we have to divide both sides by 6 to get it in that complex form. So 2 out of the 2 and the 6 leaves me with 1/3. And a 2 out of the 2 and that 6 leaves me with 1i, or just I rad 14 over 3. So again, my solutions are not the 1/3 and the I rad 14 over 3. My solutions are this whole binomial expression, once with a plus and once with a minus. And because of that I, that's what makes the whole thing complex. So we have a total of 2 complex roots, just like the last problem. Moving on to the idea of complex conjugates. This may be an idea that was just kind of roughly introduced in Algebra 2, but we're going to spend a lot more time with it in Precalc. So first, complex conjugates mean that imaginary roots always come in pairs. So notice that when we use the quadratic formula, we had a plus or minus and a plus or minus, and that when we square root, we got a plus or minus. So what this tells me is that anytime a plus bi is a root, a minus bi will also be a root. So what happens is the plus and the minus sign in front of the imaginary part switches, and that's what gives me my 2 solutions. So if 2 plus I rad 3 is a root, 2 minus I rad 3 is a root. If 1 minus 4i is a root, then its conjugate, 1 plus 4i, is a root. So notice that it's the sign in front of the imaginary part that's changing. So if I solely have an imaginary part of the complex number, if 3i is a root, its conjugate is negative 3i. So that's what those complex numbers would look like. It's just that the real part is 0. So folks, this idea of complex numbers and our rational versus irrational roots, these are all going to be important items as we move on to our next page in the notes. In the next video, we'll be starting page 4.